Oh, okay. Thanks.
So yeah, if you had to switch, let's say you didn't have, like, you don't have your software installed, so maybe what you want to do is go to Robotics Unit 3, cut your losses, and then get them to install the software you need, and then go back to that afterwards. I've done that before and taught Unit 3 before Unit 2. They're kind of interchangeable. It really, you can do robots before CNC. It's really, it doesn't matter which order you do them in. They're really kind of separate. So that kind of works out for you. If you know, if you get your,
Well, maybe, so you're saying I probably should just skip, I mean, not even start the
well,
speed to,
if you're already into it, check and see if your CNC Motion works. This software, do you have CNC Motion on your computers at school?
um,
It would look
I
something like,
don't think so. What does the icon look like?
I don't know. Let me see. It looks like that.
Or wait, I can just search. Looks like, okay,
Yeah, I don't know
maybe.
where anything is anymore because I just use the search. Um, it comes up CNC Motion for Intelitech.
No items match this search.
Okay.
So no, I don't even have that.
So then that's a problem because you can't even do hand coding and simulate it, because you could do your hand code and simulate it using the software. When you do your yo-yo or your initials, your CNC initials,
Mm-hmm.
the software to simulate it before you ran it on the machine. So if you don't have even have this software um, installed, then you've got a problem, a bigger problem than you had before with just not having HSM. So if I were you, I would switch over to robotics and then go back to this once they install the software. But I would definitely make a list of software that they need to install, like CNC Motion, for whatever machine you have. When you paid for your Project Lead the Way fee, you paid for all of the software, and it appears you don't have a lot of it. So um, you might want to be looking ahead too to see another piece of software you might want to check. And if you want to check right now, check and see if you have a piece of software called RoboCell.
I do have that.
Okay, because you need that for the robotics unit. So that's a bonus. And when just check and make sure it opens, because just because you have it doesn't mean it's going to work.
Okay.
Um,
I'll check
Chris,
on that one.
this is Scott.
oh, Scott, how you doing?
Hey, good.
Hey, Jim. I think Jim's here.
Hello.
And another piece of software. So while you're at it, Gail,
Mm-hmm.
check for flow arm, or Scott too, for the robotics unit. You're going to need flow arm project lead the way. It should open and look
Okay.
like that.
It's a simulation software?
Yeah. Yep. This is for the loose motion robotic arms. The little
Okay.
motion robotic arms.
Yeah. I've got I have a little different setup in my shop than you guys.
Mm-hmm.
Because I actually have industrial robots.
Nice. So what
Oh
you
yeah, I
have
have
to do,
three.
project lead the way, it says you have to ship those to me, and I have to swap
Yeah.
my Lynx motion robots. Okay.
So what you going to do with this 4,700-pound robot when I ship it?
Tell you what, I'll come pick it up. How's that?
I got one you can come pick up.
Well,
I'll make you a trade.
yeah, I just got an LR mate. It's just
Okay.
they just installed the electricity to it yesterday. I have yet to fire it up, but it's sitting in the back of the room. The kids are building a work cell out of it.
Yeah, I have a full work cell with 3 ABB robots sitting in
Nice.
there.
That's awesome.
So I can um, I'll use the simulation, but when we go out to the cell,
Mhm.
we actually will program on the ABB robots.
And what's really nice is the RoboCell software that I was just showing you. Make sure that you have that installed, because
Uh-huh.
I believe that you're going to find, at least with the Fanix, Open the project. Find a example. When you go to write a program, this stuff over here really, other than this is in text, and what you're doing on your ABB is on a teach
Yep.
mode.
Teach mode, yeah.
It's exactly the same. So when you use inputs and outputs, it's exactly the same. When you use jump twos and jumps and go tos, it's exactly the same. So this is a great piece of software to use as a workup to that. Even though the picture doesn't look like your robot, the language itself is the same, and the activities in the curriculum are dead on.
Okay, now let me ask you this. I don't see a tool center point. With the ABBs, you're required to set a tool center point or not set a tool center point.
This robot's smarter than that. That's all built in. So you don't.
Okay.
So there are going to be the differences. You don't have to worry about tool center point. It's already, since it only has a gripper, it's already set, and it's set exactly right there. This is just simulation software.
Okay.
So it'll get you the logic to do what you want to do on those.
Basically, I'm looking at where you're starting at basically all the way up to line 5. That would be once I get to line 5 where you have a remark for me for my programming, that would be ABB specific, and then everything after that looks like it's pretty much in line.
Yeah.
And for the most part with this system here, you'll be able to bring in mill, you'll be able to bring in a welding torch if you wanted to. For the most part, the nice part about it, since you only have 5 robots, is you'll be able to load this on every seat that you have in the lab. So you'll be able to kind of circulate your kids out into the lab for your big robots while you've got kids kind of running through this. And you know as well as I do, whether the kids are going from FANUC to robots to KUKA robots, whatever, they've all got a little bit different language anyways. So this software just kind of gives them a little bit of a gist of, you know, how to do this handshaking. There's some inputs and outputs that they've got the robot can turn on and off. So really all we kind of want them to get with this is the philosophy of movements, how should I pick stuff up, how should I put stuff down, collisions, those types of things, staying out of different ways. It really just has a mechanical gripper on it right now anyway, but it'll be kind of good for you to be able to have kids circulating through this all at one time while you can pay more attention to the kids that are out running the big bots.
Right.
Yeah. Yeah, because I'll tell you a funny story that happened. That we were doing a testing. We did a handoff of a chair a couple of years ago. And first time they did it fully automated, I wanted to actually video it, and I wished I would have. And of course, they had the timing a little off, and the one robot didn't let go in time. Now, this is a school chair. I'm talking about steel framed chair. That industrial robot showed why you have a test cell, because it ripped it in two.
Nice.
I mean, yeah, and I didn't get it videoed, and I was so mad. And the kids thought they messed up. They were like, oh, you know, there's a big gasp because it ripped this chair in two, and I was like, oh no. And they're like, Coach, we're so sorry, we're so sorry, we're so sorry. I said, no, you don't understand. We didn't get it videoed.
All right, go grab another chair, folks.
They're thinking we're in trouble. I said, no, we needed this video. I said, why? I said, this is a perfect moment. Because it literally, those two robots tore that thing in half. You're like, oh, wow, this is cool. So it was a good lesson for them. And the fact that I have these, we got them from BMW years ago. And so we have used them for all kinds of things.
Awesome.
Over the years. So they donated 48 of them to the state of South Carolina, and we were one of the schools. We got 3. I'd have taken more if they'd let me have them.
Right.
They wouldn't let me have them.
Right. So like Jim said, this software is great because you can have a whole class of 25 kids doing this while you have 3 or 4 back on the robot doing their thing. You focus on them, and the kids are doing the activities right from the Jim, is that your Justin Bieber playlist?
It's not me. Because I can, when you take a look at the curriculum, the majority of us in one way or another use RoboCell as an opportunity to kind of keep kids on track while we're doing something else at the exact same time. Because the way the curriculum is built up is it's really just a tutorial, kind of a step-by-step, follow me, do me, those types of things. So like mine, my kids are finishing up their container designs for CNC CAM, and once we've got all that finished up, then it's just babysitting these mills. And once we've run the prototype and we've made sure that the container works exactly like it is, then it's just I'm going to stand there for 50 minutes while the CNC machine hogs out all these parts and everything. And for the most part, now I just grab a kid and it's your day to go babysit the mills, and it works out pretty evenly for the kids to all get their time on the mill. Because it's CNC. You just basically are watching it and making sure nothing crashes. But the rest of them are just sitting in the lab going through these tutorials, and I don't have to baby them or spoon feed them. I can go out and help watch the equipment and make sure that my $20,000 mills aren't crashing and kids are in there at least with something busy to do.
Sure. I've got now my mills are a little different. I've got 3 mills. 2 of them are Boxfords, which I got from the machine tool program a couple of years ago. And I've actually got a Boxford lathe also. It's a CNC lathe. So it gives me a little bit different look, because these are actual mills that, could be in production somewhere.
So yours aren't the little Boxfords that are ran off of like a router?
These are little Boxfords, but they're actually considered portable Boxfords. And the difference is they can do full milling. They're just small. The school bought them back when we had a full machine tool program, and when the machine tool instructor left, I went down and got them because I was afraid stuff would leave if I didn't. And we spent, I don't know what we spent on them, but it was pretty good money to get all these in here. So ours are all computer controlled, and most of this stuff that I see when I started looking through the curriculum today, because today's the first day I looked at the curriculum, is right in line with what the programming for the Boxford is. So that'll help a lot from the standpoint of them being able to do simulations and stuff.
Yeah, the only thing we'll have to do is we'll have to figure out what coding you have to try to get you the right post. That's not a typical mill that I have seen on most of the lists, so I'm going to guess in one way or another it's probably going to use a simple FANUC code.
I think so. And I should know, but I don't, because it's been at least 7 years since these were brought into the building, and I haven't done a lot of work on these. I've done some, but it was just when we were initially trained. We had a full-time machine tool instructor and myself, and we're both certified in machine tools, so I just don't remember when they brought it in what we had. I've got all the software, so it'll be easy to check. That was kind of a different scenario for us because we had full programs and then we got rid of it. So, but I held on to all the CNC stuff that I could get my hands on. So it didn't walk out of the building. Everything else is gone now, except for that. So.
Well, good. At least you got that.
Yeah, when they closed the program, I was very disappointed. And the thing about it is we have a training center next door that's next to us that our kids now go over to be trained in machine tool. When we had a perfectly good machine tool shop 2 rooms over from me. And the guy that they let go and had forced retired teaches 2 days a week, that class now, through an agreement. Like, we lost our minds.
So I just looked through the CAM, and it doesn't look like we have one there. So if you don't have the support number to Project Lead the Way, let us know and we'll get you that. But you're going to want to talk to Project Lead the Way support. They will contact Autodesk. They will tell them what you've got. They may ask for a sample code of what you've got from either a book or anything that you've got that previously had some code in it. And they can kind of just look at that, and they can either tell you if they've got a post that already does it or if they need to produce up a post. Typically, with most softwares, whether you're dealing with Mastercam or SurfCam, any of those, making the post, the companies that are doing that, that's usually the expensive part. So we'll see if we don't already have something that works, or if Project Lead the Way can coax Autodesk into making one, because making one on your own, I've seen some people do it, but that has not been, that's not my thing. I'm not a post guy, so we'll have to try to get you to the right people that'll make them.
Okay. Yeah, I don't want to have to do that. I would not. Yeah.
So, question-wise that Chris may have already asked is, anybody got some hand questions, hand coding questions as you went through your NC codes? Any problems that your kids ran into? Any code problems that you saw?
I'll let you know in about a week because I'm just starting. So.
Perfect.
Okay. Gail, Brian, Nathan, any of you have some? Have you gotten through this G&M code?
I've done it myself and done my initials into the wax just to learn it from my end. That was before Christmas. The kids haven't got to it yet.
How did that go for you?
Once I got the I can't think of what it's called, the piece locked down into the mill firmly, it went really well. The first time I didn't have it down firmly enough, and the block moved all over everywhere, and I had to stop that. But
do you have a pneumatic vise or a manual vise?
Manual vise.
Okay. Do you know, is it a screwless vise or is it a screwed vise?
Oh, I'm sorry. It's a pneumatic. I just don't have the pneumatics hooked up. So, and I can't. I just was having a hard time. The one piece it has a little screw that I can adjust, and then the other side is pneumatic. And I don't know. It just took me a while to figure out that the bracket, like basically to get it set right, the one bracket is just barely holding the vise down. I mean, the bracket might be half an inch long, and then I've got, like an eighth of an inch of it actually resting on it. So I didn't think it was going to hold, but it did. I don't know if that makes sense, but
might want to take a picture of it and send it to us, and we'll take a look at it.
Okay.
There's multiple problems with the air vices. One of the biggest ones is the air vices are really set up for one specific size. So if you're going to do a 3-inch by 3-inch whatever, you set the vise up for that. Because every time the vise comes in, when it's a single acting vise, it's just basically coming in at an angle and supposed to squish it into the corner. Well, if your parts aren't exactly the same size every time, then you're going to come in contact with one face instead of both faces, and you're right, you're not going to hold on to it. It's going to constantly keep letting go, especially if you're not really holding on to enough of it, 3/4 of an inch or so.
Well, the pneumatics aren't even hooked. The pneumatics aren't even hooked up, so I mean, I'm just kind of clamping down as best as I can with it as is. I probably should just get a manual vise. I think I have a little money I can use for something like that, and I know we've talked about it, and you gave me some names of some things. Maybe I'll send you an email. If I can't find it, I'll send you an email, and maybe.
Yeah, absolutely, because I know Chris has been happy with his screwed vise. Mine, just because of space and everything, I've been using the little screwless grinding vices, and I've had good luck with those. Just like the one that's in the photo there, that's a grinding vise. You can get them in a couple different sizes, but you got to watch where you're getting them from. They'll range for almost the identical vise from $100, and then somebody else will try to charge you $1,000 for them. So you kind of have to watch. Intellitek's, I forget how
Okay.
much they are, but that vise right there, I've got almost an identical vise that I can't tell the difference
Uh-huh.
between, and I paid like $120 for it. And when I tried
Okay.
to get one originally from Intellitek, I forget what it was, but I almost choked on my tongue when I was trying to speak back and tell them, you've got to be kidding me. I have two of the pneumatic vices, and the very first thing I did was
Uh-huh.
yank them off there.
Yep, and they take
Okay.
up a lot of room, and you got to be careful because that hydraulic cylinder, sometimes if you put it on incorrectly, the hydraulic cylinder's sitting off here,
And
and
that's really where it should be. The way they've got it, it actually should be up against the
Left.
shield. It's the vices are designed poorly. Their static vice,
Yes.
for us, the majority of the time should be on that front right or front left corner, and that's exactly where their cylinder is. And it's just a bad placement. So if you put it where they think it should be, that's a wonky place to put your origin.
right.
Hmm.
I think the
No, I will say, and I don't know if this is the right time to bring this up. I've been trying to run HSM on that first, I forget what the part was called, the first little sample
flange.
widget or whatever it was. Huh?
The one from us or the one from PLTW?
The one from PLTW.
They
I
only
mean,
have
you did it
one.
one day too.
The flange.
They have one file. They have the flange.
The plans, that's what it's called. And I keep nicking, I think, I want to pull it back up. I'm sorry I don't have it right now, so maybe you want to move on to someone else and I can ask my exact question when I'm looking at
Same thing.
the
Anytime you
file.
run into some of those things, that's really what Chris and I are for, is to try to help you out to not have to poke around and figure all of it out on your own. There's some trials and tribulations that Chris and I have already kind of gone through that can kind of help you speed up the process of, the learning curve anyway. So if you've got some problems, take some screen captures and fire them off to us, and we'll do anything we can to dig you out of the hole.
Yeah, I'll do that. I'll send you a screenshot of it with my actual question, and
The
I'll
biggest
mention
problem
the
with a
next time
flange
that
is
you take
usually
care.
that path around the outside. That path around the outside, we have found that HSM does not like to plunge. It always wants to either ramp into it, or it wants to do a helix into it. There's a couple different strategies that it has built into it. So if you don't go through and actually change a couple of the settings, it'll always dig into the part. It's
Okay,
just
and I
a
think that's
strategy.
exactly what's happening. It's not plunging straight down. It's kind of coming
Yeah, it's
in
not
and
designed that way.
lowering as it moves in.
They don't like that philosophy. They don't like the philosophy of full engagement on the bottom of the tool as it goes into the part. That's just HSM on its own.
Okay.
You can slot it instead. The really cool part about a slot is it will ramp, so it'll start up at an angle and it will start coming down to it, but it'll even ramp around a corner. So it can start on a flat area, and then as it goes down around the corner, it will continue to move in at an angle. So slot will work, and then if you tried to do it as a profile, there's a couple of settings that we can show you that you can take off of there and change them into 0, and it will no longer.
Okay.
Basically, theirs is a roll-in. It will come down, and then with a Z and X axis, it will roll into your groove, and it almost always digs into the edge of the part.
Okay. So let's see if I followed at least part of that. So I think I used a contour, and you're saying I should use a slot instead, and that might
Either
fix the
way,
problem.
the only problem with a
And then
slot
there's some
is
settings in the
geometrically that's
contour
not
that I
truly a
can change.
slot.
Okay, right.
A slot would be an even path, a nice offset all the way around. And whoever designed this originally, the fillets that are in those corners, they're the same fillets. It's not an offset fillet. So it's not truly a slot. Some of your kids may have a hard time getting HSM to want to call that a slot. Some will do it right away. I don't know why this year I had, probably 50% of the kids that tried slot. It worked just perfect. The other 50% did it the exact same way. It just wouldn't accept it. It just doesn't like those corners.
So probably the better way then, I don't know why.
Doing it as a contour is fine. It's just on the very last tab of the contour, you have to take away, shoot, I don't even remember what it's called. It's called...
You want to show your screen, Jim?
I'm looking on my screen. It's called the lead in and lead out. You have to uncheck the lead transitions.
Okay. I'll
If you
check
take
that out.
those away, then it should fix your problem. If your problem is what I'm thinking of off the top of my head.
Here, let's switch
Right.
over to you, and then you can actually show them.
Okay.
There you go.
So let me open up. I think I still have a flange. Oh, come on.
And then on your guys' website, you have some more practice parts. Is that right? And you said you kind of, is
Yep.
the flange the one you use as your actual like quiz?
Yeah, that's the
Or am
way
I
Chris
missing
and I are
something?
doing it this year.
Okay.
I don't know where my flange is. I'm just going to make a part real quick. I just cleaned off my desktop yesterday, and I think I trashed them. So whoever designed the flange, if they had originally designed it like this, that type of thing would have been fine. It sees that as a slot. That's an even path. It's a slot basically wants to compare the two outside walls and then wants the tool to follow the middle of those two walls. Well, if those corners are like they designed it, which is more like they designed it like this. So these fillets are identical. If this is 0.05, then this one's 0.05, and HSM doesn't truly understand that as a slot because it's not. There's not an even path between those two, but regardless, this will still work for our example. We'll cut that. Okay, so we'll go ahead and you're using a contour. So if I select the, oops, I guess I gotta do setup first. Okay, so it really doesn't matter whether I contour this one or contour that one. Regardless, you're going to leave something. So if I'm going in there with an 1/8 inch tool, I'm either going to leave a little bit on this outside or I'm going to leave a little bit on this inside, depending on whatever it is I contour. So regardless, it really doesn't matter. So we'll go ahead and I'm going to say that my bottom is there, whatever, I don't care. Let's just pick a quick tool. So it has to do with these two here. If you don't remove these two, actually I think you don't get to see really a good picture of it, but it'll actually plunge through your part and then roll into the part. So I don't know if I can.
Jim?
Yes.
Scott, I noticed that you've got CAM up on your Inventor.
Yeah.
Where's that setting at?
You have to install it.
You have to install it?
This is an add-in, so you have to go back to where you got your Inventor from, and you want to install the HSM 2016 Pro.
Okay.
When you install that, then you'll have the CAM tab. So here's what it's doing right now. It's following this green down, and then the green is rolling into the part, coming over to it, then going around the blue, then it rolls back out of the part. So you're going to see when it actually goes in the simulation. Show my stock. Don't show my holder. It'll plunge into the part and then go over. So every time you're going to get that too much every single time. That's because of that strategy they have. That's their lead in and lead out. So if instead I come into my contours and I remove that, say I don't want to lead in nor lead out, then it will actually plunge. So now you should have one straight yellow line that goes straight down to it and then around.
And you'll know too by
It's too bad you can't get it to kind of roll in along the actual path you want it to go.
You can if it's a slot.
Right.
So if where's that? I want to suppress that. Yeah, go away. And then I'll pick a slot instead. Oh, wow.
But since it's not really a slot, it seems like the better thing to do would be a contour.
Well, ideally, a slot is really a better option because a slot is going to leave you a little bit wrong here and a little bit wrong here. Regardless of whether you do a contour, you're going to be wrong more on one side or the other. It just happens to be the way that it was designed. It should, and that's one of the things I talk to the kids about. Because if I was going to do this in reality, and whoever designed this, engineered it, blah, 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 whatever, I should actually redo this. I should come into this corner and I should remove this little tiny part, because one way or another, if there's something supposed to fit down into here, you know, I'm not going to machine it the way the engineer designed it. So in reality, I need to come back in here and I either need to contour it a second time or I need to attack just that corner, which I usually don't have my kids do. I have them go back in and do a redesign and fix that corner to be a true offset.
So to get it the way it's actually designed, you'd have to do a contour on the inside and the outside edge, 2 tool paths, or I suppose could you also do a pocket on it and have it pocketed out?
Sure, but the bad part about a pocket is it's going to wobble.
Okay.
Most pockets do not like, let's say, you have an 1/8 inch tool and an 1/8 inch groove. Most pockets don't like that. There's no tolerance.
Gotcha.
So when the tool's going in there, there are a lot of times that it just won't do it. It says that it's not physically possible for an 1/8 inch tool to make an 1/8 inch groove just because there's no room for a pocket. So this should work.
So then you'd end up having to use a really small bit, I guess, and then it would take forever.
Yep.
Let's see if this slot, nope, see, for some reason, every once in a while my kids can get it to work, and this time, like, oh, I may have too big of a tool. I don't even know how. I just drew this up real quick. So I don't even know what kind of distance I have here. So I was trying to do it with a 1/16 inch tool, and I don't even have a 1/16 of an inch in there. So I've got to go back in and so I didn't do that with any dimensions, so that's why it's not liking that slot. So if I come in here and I say slot, we'll try it with that 1/16 inch tool. So I want this pocket and that pocket, and I want it to go to the bottom. All that should be fine. We'll see if it'll actually slot it. No, it's crashing because of these corners.
So when you redesign it, is it just the offset command that you're using to make sure that the two are
Well, so if I was really
matching?
truly looking at it, if this was 0.07, then this fillet here should have been plus 0.07. That should have been a nice smooth contour around there. So whatever this outside fillet is should be this original fillet plus the distance in between the fillets. That defines a true slot. So that should, since it's a Tuesday, it'll probably give me problems, but that shouldn't give me any problem. But
and with the if I just went into sketch mode and then did the offset command, would that create that same thing, or is that not what offset does?
Offset will ruin it won't keep the radius the same. It'll offset, but it'll change the radius in the corner when you use the offset command.
Which is what you want. So here you can actually see it. So your question was, it would be nice if it could contour around, and you'll actually see this is doing it. So this red line you can see is actually coming down, and as it goes around that corner, it's diving into the parts, and that's what it likes. So it's not actually plunging. So it's coming down to the safe position, and it's rolling around these corners, and I don't know what their angle is, but they have some kind of angle attack on that ramp, and it will keep going around until it gets to the bottom, and then it will go around and come straight back up. So that's the advantage of a slot. If it truly is defined as a slot, then it's great. It gives me exactly what I want it to do. It's just that another one is not a slot. So some kids, for some reason, they got it to work. I don't know how they did it without redesigning it. Somehow they got some kind of glitch in HSM to accept it, but most of them could not.
But clearly I can have the kids either redesign it or I could redesign it myself, and since, I mean, I'm not using the LMS, I'm using Moodle, so I'll just post this on, I mean, I have to already download it and post it for them anyway, so I could always redesign it and then post.
Sure.
And then, and then life's a little bit easier.
So, Gail, what have you got?
Well, I think you weren't here yet when I talked. I am having issues with my IT department, so I don't have the right software installed. They do not have HSM installed even. I mean, I've gone to my administration and they've tried to help, but it was supposed to happen over break and didn't. So I talked to Chris about possibly starting with Unit 3 now,
Uh-huh.
and but I realize I have to make sure flow arm and links motion are installed as well.
And one thing that you may want to do is just, I can guarantee it's going to give you a real leg up for your CTI this summer, as if you go ahead, like some of the videos that Chris and I have on the website, or some of the videos that are embedded now into the curriculum. They sent out an email, shoot, it was, I don't know, very beginning of the school year, saying that CIM had an update. Some people went ahead and updated their CIM, and some people did not. If you updated your CIM, then it actually has some HSM stuff built into it now. And if you don't, then I would just go to Chris and I's website, and I would at least watch the videos. That's going to help you out so much when all of a sudden you get to summer training and they're going to say, hey, do these couple activities. I mean, you're not going to lose any sleep, and you're going to have stuff done, and you'll be able to watch some HBO and do what you need to do and not have so much stress during the summer. You wouldn't believe, if you've not been to a CTI before, CIM is so software intensive that you're learning VEX, Robot C, you're learning CNC motion, you're learning HSM CAM, you're learning RoboCell, you're learning FlowArm, you're learning Inventor, and it can be a lot of late nights. So anything you can do to kind of give yourself that little leg up, even if you don't have the software, hopefully we can. Do you have a school laptop?
Yes.
So I would see if they couldn't at least get it on your laptop for you. I mean, you could even do some cool stuff and show the kids. And like I said, that's going to give, because you're going to have it installed for this summer anyways.
Right. Well, I mean, I'm still working on it. I even had the Project Lead the Way guy talk to one of our IT guys, and so I'm baffled at the holdup, but it is stifling what I can do with the kids. We do have a laser printer, and I've been able to teach them some of the similar content, but I haven't been able to stick with, especially Unit 2.
Yeah, that's a shame.
With the Project Lead the Way.
That's the big thing, is the way the CIM curriculum, we've tried to develop it, and we're continuing to work on it every year and try to make it better and better every year. It's really to try to help out so that you don't have to try to invent the wheel. There's supposed to be enough activities there that even if things go awry, that you've got something to go back on. So like you said, go ahead and jump in to Unit 3. Go ahead and have some good success with that. There's no questions on the final about CAM and that type of stuff anyways. There is tons about CNC hand programming, that kind of stuff, but it's more about getting your bang for your buck out of your mill. And when you spend so much money on those mills and you've got such cool equipment, it's really the wow factor and the carrot for a lot of kids to get into your classes, to see some of these things and see these machines hop to life and make these really cool stuff. So, if you don't get to it this year, I wouldn't stress it.
Well, I mean, I've got such a great group of kids. I really want to, for their sake. So I'm still trying to do it, but I appreciate the advice. I mean, knowing that I can switch these around helps alleviate some stress.
Yeah, Unit 1, 2, and 3 really can be, well, I won't say that. Unit 2 and 3 can be mixed up. You kind of already have to have VEX before you do Unit 3. Because 3 is going to ask you to use VEX with the robot, and if you don't already have kind of a comprehension of Robot C, that would make that really difficult. But so you could do 1, 3, 4, 2. I mean, 2 is really all on its own. 2 can be done at any time. Yep. 2 has nothing to do with anything else. You could do 2 first, you could do 2 last. It's kind of its own little thing.
Okay, well, maybe they'll have it done over spring break. I could do it then.
That's the optimist.
Hey, the Colts' coach got to keep his job, so that means miracles happen.
There you go.
Lord knows how.
Yeah, that's what I said.
I just put in the
Blame
chat
it on the quarterback.
a link to the HSM tutorials on our website. I just put that in the chat. So if you want to copy and paste that to your desktop or whatever, that'll get you there. And all the parts are there. Everything's there. You just have to click on the right links and it'll take you to the post. Like some of you will want the post for the machines. The post is there. It's all there, so you'll be able to use that.
Thank you.
Yeah, yeah.
And Nathan, how about you?
We chatted already.
Oh, that's right. Duh.
Scott,
I drink a lot. Not at school. Not anymore.
you have any questions, Scott?
Just trying to take in everything as far as today's first day I had a chance to look at the curriculum. I teach 3 of the other classes, so
Okay.
I teach ID, POE, and DE.
Well, and again, this is really for everybody. Again, the way our curriculum is really kind of divided up is we're divided up into your basics and your control systems. We're broken up into your CNC, manufacturing, how to actually make things. We're broken up into the robotics, and then we're the put it all together factory, which is supposed to use a little bit of everything, which honestly the majority of the time doesn't use much of or any of Unit 2. I mean, it doesn't need to. It really just uses your robots and uses your VEX. So with you having the large robots, the original, many moons ago, the original plan was to do handshaking between the big robots and the mill. So you would grab a robot, the robot would take some material, shove it into the mill, the pneumatic vise would close up, and then it would run something. So you were trying to create basically a little cell. The majority of what our students are creating now is simulated cells, since we have the little robots.
Right.
So on Chris's website we have, if I just type in factory, you'll see that there's a whole bunch of different sites that you can go to. This was the 2015. There were a couple different of the colleges. So this was UK. This one was Cal Poly. There's another Cal Poly. This was RIT.
Yeah, I think so.
No, RIT was the nerve. So this must have been
See.
Maryland.
Yep.
So there were a couple different factories here. So you get kind of just looking at the picture, the kids are building either some kind of simulation, or sometimes it's not even simulation anymore. Sometimes it truly is actual little factory. Last year, my kids, one of their factories was a what are they? Oh, the Peep Bunnies, the little marshmallow bunnies. It was a Peep Bunny disassembly factory. So they had used pneumatics to disassemble one of those marshmallow bunnies. So actually it was multiple. So it had this little feeder, pushed the bunny in, and then it removed its ears. So it kind of sheared those off and put those in a bin, and then it removed its head and put that into a bin, and then it had these little bots that took that out to separate factories. And I don't know if their plan was to then bury the bunny or do what, but that was their little factory. I had one last year that was a fingernail polish painting factory. You got to pick the color that you wanted, and the robot went over, picked up the brush, and it not so accurately kind of smudged fingernail polish onto a person's finger. So some of them have been fairly simple, and then some go way over the top, make something pretty complicated.
So I guess my writing exercise with a 2-ton robot fits right in then, huh?
Yeah, absolutely.
Sure.
That was one of the when we first got these. That was one of the first things we did was learn. I taught all the kids to write with them, and of course, it's teach-pendant programming completely. And then we did put in a Festo PLC so we could make the cell work several years ago. So
that's one of the big things that's really missing from the curriculum. I have gone out and purchased a bunch of PLCs, but really we kind of use the microcontrollers, the VEX box, as our PLCs. So that's really what's being used to do the controlling and the communications between the robots and whatnot. But if you have some PLCs, by all means, Unit 1 is really kind of where it fits the best. But get your kids, if you've got some Allen Bradley or Siemens, whatever, and kind of show the kids what some industrial stuff looks like if you've got it.
Yeah, I've got a couple of Siemens, one Allen Bradley, and the others are Festo. So, because our end effectors have all been Festo, so every single one of those are Festo for the robots. That was, for us, it was just easier because Festo's was close, and we were able to make some good transition plates and for them without really modifying anything on the robot when we got them from BMW, because BMW had used Festo as their some of their end effectors, and the particular robots that we got happened to have one of them had a transition plate on it already that they didn't keep, that they said they didn't need. So we were able to take that and actually redesign it. We took it up to our machine shop and redesigned it to match our Festo equipment that we bought. So it was a little, for us, that worked out a little better from the standpoint of that situation of having those robots. Unfortunately, one of them I've got to troubleshoot now because it doesn't work. Not really for sure whether it's got a bad battery for my resolvers or what it is. But anybody wants to come to South Carolina when it gets warm, help me troubleshoot this thing. You're welcome to come.
Did you send me?
Oh, I'm gonna pass.
Yeah.
So it sounds like a lot of you have had at least some individual success with G&M codes. Some of you sounds like you've been able to open up the flange, the practice machining, and kind of go through some of that a little bit. Just do what you can, keep having success with the kids, and kind of keep them still excited about it. I would kill to get some more of my kids into industrial engineering or manufacturing engineering. It's such a needed, in such a high demand field right now. It's just apparently not as sexy as mechanical or electrical or civil, or I don't know why civil's sexy, but anyway.
And that's why this is so interesting too, because where do kids learn about this stuff, or how do they find out what's cool and what's not if they don't have a course like CIM? So this is a great introduction to it. And one thing and I was just thinking about this, Gail, was the fact that, okay, so you're stuck, but what you can do before you move on to robots is have them design this container and do the inventor work now, go into robots, and then once you get the software installed, go back into the CNC to machine this part. So you really, that's another option too. While inventors still fresh in their minds, stick with the design of the container, and once you get the container designed, then say, okay, well, we're going to go into robotics and then come back.
No, that's a good idea.
That might be while they're still doing inventor, and that's what we wanted to kind of show you now. Jim's got up on his screen. He's got the design strategy for a container. And what we tried to do.
Okay, I can't see the screen. I don't know if it's just.
Can everybody else see the screen? Yeah.
I don't know. I can see my screen.
I can see it.
Should I go out and back in, maybe?
Try that, Gal. Try that and see.
Okay. Okay. I'll come back.
Okay.
So the idea is when they originally designed this, this is designed in a two-part. This just uses a lot more material but gives you a lot bigger base. So there's a base here and there's a lid here, and because the lid is made out of such thicker material, it gives you the ability to do some really cool contoured stuff and some inlaid stuff and things up on the roof of that. The way that the majority of us are doing it now is to save material, is to do it more like this. We've got the base on one side, we've got the lid on the other side, there's a boss in between it that the vise can hold on to. Once you've got it machined, we can split it right in half on the bandsaw, and then once it's split, we can use a custom fixture to hold back onto it to be able to do whatever we want on the top, whether it's a simple facing operation and then an engrave, or a face and a pocket, whatever it is that you want. So I went through with my kids today, and this was a simple container that we went through for our demo, and we've got a bunch of different options on the website that you can kind of go through to see how I would do it. So really the idea is you want your kids to kind of think of it as a solid. Use whatever envelope you have for your mills. My mill takes pretty nicely a 3-inch by 3-inch by 2-inch thick. So we're really looking at something kind of more like that. So that's kind of what I give my kids as their constraints. And what we did today is I printed this document out, and they all started filling it in with me. So stock width was 3 inches, stock depth was 3 inches, stock height was 2 inches, and so on. Okay, so once I've got all that, I tell them that in real life, most people when they're designing things, they don't truly think about, okay, well if I'm going to design this as perfectly a 3x3 and my stock is roughly a 3x3, I can't get the part out of there. That means I got to go buy a material that's bigger, and you can't go buy a material that's a 3 1/8. It doesn't come that way. It's, if I'm lucky, I'm going to get a 3.5 by 3.5, or if not, I'm going to go up to a 4, and I'm going to have tons of wasted material to be able to make this. So what we do instead is we design it out of the stock rather than design it and then try to find stock to fit it. So what I have the kids do is there's a safety boundary. This allows me to not be accurate when I'm making the raw stock, and allows me to not be accurate when I'm trying to find that corner in the mill. I can just throw a stock piece in there, and regardless of how accurate I put it in there, I've got enough extra material around the outside that it's going to make my part just fine.
And before we,
go ahead.
Before we leave today, I want to steal the camera and show you exactly what he's talking about, because I have a bunch of examples here in front of me from my lab, and I'll show you exactly what he's talking about.
Then they get to have a little bit of fun. They get to decide, what kind of pocket it's going to look like, and then they go through the rest of it. They make the lip that's there, they make the pocket that's there, and then we steal all that geometry and push it over to the other side so that it becomes a parametric container. That way, I told my kids, I said, so what happens if all of a sudden we've got to change the original thing to 2.5? Well, if I've got to do that, the way we've got it designed right now, it should do it just fine. If all of a sudden it's no longer a 3-inch, or a 2-inch and it's 1 3/4 inches, I should be able to do that, and it should be able to adapt itself to whatever criteria I currently have. So now that they've got that parametric container, they can kind of go through and do what they need to do. But we've got a bunch of videos, and even this is a link out of our page that will go through and show you, a lot of the different ones. And it doesn't have to be something that's symmetrical. We do go through, this is not necessarily part of the curriculum yet, but teaching them how to make custom fixtures, well, that's the only way to hold on to something easily. This one is a custom fixture, this one's a custom fixture, and so on, so that we can do those contours along the top. Even if I'm just making it flat and doing something on it, I still got to find a way of locating all of that. We've done some with inlays. We've done some with multiple acrylic inlays. We've done some that have been lasered. We've done some with some polished aluminum inlays. We've done some that have stuff on both sides. Really all kind of depends on the amount of time that you have to be able to do a lot of your containers. This gentleman here, he bought one great big sheet. This is about a $300 sheet of acrylic, and he made all of his containers at one time. He has a fairly large mill, so he stuck this one great big sheet in, made him some counterbore points to hold on to, and he just let it run. I forget what he said, how long it took to run, but it took considerably longer. Mine take about 30 minutes a container, and I think this year we'll try to knock some of that time down so I can get 2 done in a period.
In my class, since I've got a little bit tighter schedule, I try to knock it down to between 15 and, so if you look at some of the simpler containers with the flat tops, we don't generally do surfaces in my class. We do the flat top, and that cuts it down to like 8 minutes a container, 8 to 10 minutes. So then you can get more containers out, and then we use the laser to engrave on it. So just different things you can do. You look at some of the containers. That was a ring box. One year, a student, we have a competition to see who comes up with the coolest design. In that particular year, a girl made a ring box, and everybody loved it, so everybody got a ring box. We did a mass production of that ring box. One year it was cards, a deck of cards. I don't remember what actually went in that one, but it was part of the design process. And when you do round things, you talk about indexing. You take a look and you can see how things index and stay in place. And it can get a little more complicated too. And as you go, I'll show you some examples. If you don't mind if I steal your screen real quick, Jim?
No, go ahead.
I can show you exactly what. Share my. Let's see. I'll make me the presenter. See if this works. And then I will share my webcam. Can you see my webcam?
Yep.
Okay.
Yeah, there's some kind of monkey on your webcam.
There's this was the first container ever built in our tech lab, the first year that I taught this course. And if you look at this container, we made a 2-inch by 3-inch container out of a 2-inch by 3-inch block. And you see the saw marks, the saw curves where it was cut out? So if you don't design right, what Jim was saying was he gives them a piece of material that looks like this. Then they design a container that looks like this, but notice how the dimensions of the container have to stay inside the size of the rough stock. That will get you a perfect container every time. So if you stay inside the rough stock, and you won't end up with issues like this. But I keep this around because you can say, hey, we went from this to this, and you can see all the different things. But the first time through, do what you can, do what you have to be successful. If they're simple rectangular containers, the kids still love it. It doesn't matter. The kids will come back and they'll do different things too. But the idea was that we wanted to get through today the design of your container. So I think we pretty much have that. Is there anything else that you have questions about pertaining to CNC that we might be able to answer in the next couple minutes?
And we have that entire container that I just kind of poked at. We have that container being done in Inventor step by step. Then we have it being taken through HSM step by step. So we've got whatever you kind of need on there to kind of do a little bit of it on your own.
If you were to search container, it would it'll give you a ton of different. How do I make a container using Inventor and EdgeCam? How do I use Inventor 2013 to make a parametric container? That shows you how Jim does them with make them parametric. There's all the CIM container. There's PDF files you can download. How do I make sure my container lip and lid will fit? You'll find all these different things. I just type container in the search box up here on the website, and you'll end up with all this other stuff. And a couple of you have mentioned that you had some questions or concerns. Feel free to send us a picture. You can send a photograph of something we can take a look at, set up on your machine. Do you think this is going to work? Feel free to send us that. We'll take a look at it, and we'll give you some feedback. But other than that, does anybody have any other questions for now regarding this kind of stuff?
I have one that popped up while I was playing with HSM. I noticed there was an option somewhere, I don't remember where, I just wrote down a note about it, that said something about stock to leave, and I set that to 0 because I was assuming that you'd only use that if you were coming back with a finishing tool.
That's it, exactly. Very good. That's okay. Exactly. I would set that to 0 unless I'm going to leave something to come back and do a finish pass on.
Okay, great, good. I'm glad I understood what I was looking at.
Beautiful. Just right quick before we go, if you go to Solutions, HSM CAM Solutions, it's the only one there right now because it has everything in this one. When you go to do HSM setup, where you install the tool store and the post processor, you can download the post processor and the tool store right here. If you click on that, you'll get those two files to finish this up. And you click on these, you'll get the video. You click on this folder or this icon, you'll download all the inventor files that you need to do all of these tutorials. And feel free to use those in your classroom too.
Just as a warning, if you have IntelliTech equipment at your lab, HSM has an IntelliTech post built into it, and it has errors in it.
Right.
So the post that we have is actually the most recent post from Autodesk. Just for whatever reason, Autodesk software is not parametric and it doesn't update itself. So they have put patches out there. So if you download, I think if you download the new HSM, it comes with a new post, but I don't know that for a fact. I just know the one on our site is the newest one that I know of.
Chris and Jim,
Yes.
how many tools do y'all typically use for making one of these things?
I tend, depends on, yeah, go ahead, Jim.
One.
Yeah.
One? Okay. So you're not doing a lot of tool changes or anything?
Depending on,
No, because I only have one machine that has an ATC on it. All of my rest of my machines are manual changes, and that's just a pain in the ass. So the majority of my students, I make them design their container around a 1/2-inch end mill.
Okay.
When we get to the lid, I allow them to use a 3/8 ball and then an engraver. But for the majority of hogging out the base and the bottom of the lid and doing all the outside contours, we do it as quick and dirty and as fast as we can with a 1/2-inch hog.
Okay.
And I guess that's just one of the constraints you put on the project. You tell them from the get-go that they have to
Yes.
be able to machine it all with a 1/2 inch.
And when you look at back at that original diagram, it's in there. You get to tell them what the minimum inside radius is, and with a 1/2-inch tool, my minimum inside radius is a 1/4 of an inch. As long as they at least use that, then they shouldn't have any problems with my tools.
that it just saves a lot of time. And some years, like if you have some extra time, or I'll have kids who, say, hey, I want to stay at lunch and I want to do this, and it requires two tools. And I'm more than happy to let kids do tool changes, but when I'm trying to do a mass production, like Jim said, you limit it to one or two tools, and it just cuts way down on the time. It also cuts down on human error with the kids putting their hands into a CNC machine to swap tools in the middle of an operation.
Right.
As you saw from that video, I have a lot of gray hair. Each one of those came from a kid doing something on a CNC machine that he shouldn't have.
So, so you mentioned earlier you had like a 3x3 block, and you make them keep their design inside a smaller area. Is that basically? Does that have to be a 1/2 inch from the edge then, since you're using a 1/2 inch?
Anything?
No. I use an 1/8 of an inch offset. So that really means I'm losing a 1/4 of an inch worth of my stock. But when I go to the table saw, I just hack it up. I just go and do it really quick. Mm-hmm. So some of my blocks are just a little bit over 3, some are a little bit under 3. When I throw it into the mill, I don't worry about being perfect on the corner. I don't have to use my edge finder. It's going to curve it out of it. And I've got a 125 thousandths all the way around.
Right.
I don't have to be accurate at all. Chris, go to the Inventor Solutions. Should be the most recent one. How do I make a container in Inventor? That very top one, that's the most recent container that I've done. So there's the lid, the base, all of that, and you can see all of my numbers and everything that I utilized. The only thing, and I don't remember which mill you have, the big deal is the Benchman and the Pro mill. They're two new ones. 3/8 of an inch is the largest shank that they have. So the tool I'm using, I think in the video, I don't remember if I backed it off to a 3/8 of an inch or if I kept it with my 1/2 inch. But regardless, whatever tool you've got, you can kind of change my numbers to fit whatever you've got. But those 4 videos right there, that shows you how to make the fixture, the surface, that's the whole shebang right there. Then if Chris scrolls down, You then can take that container into HS. Oh, we don't have that yet?
Well, not yet.
Okay, so we'll have the HSM version of that container. Right now we've got the edge cam, but we'll get the HSM version of that up.
Okay. Well, I bookmarked that link you sent us earlier, and I'm going to start watching videos on my lunch tomorrow. So.
And for each of these two, what Jim did is he put together a Word document. We turned it into a PDF. And so this might be something you want to copy of for yourself that basically shows step by step. Some of us are less movie visual oriented and more step by step. This might help you out too. So this is, you went through.
Okay, I think I just realized what I was thinking, Ron. I want this container, the part we're milling, I actually want it to be above the vise.
Correct.
Yes. It's not above the vise,
Okay.
and you lose part of your vise.
That's what this boss is.
Yeah. Right. That's why I was thinking it had to be a 1/2-inch border around it, so you didn't lose the vise.
Right.
But that's what
I
that
just
big
need to
rectangle in the
prop-
middle is for.
Yeah.
Okay. And then the rest of that should stick up above the vise.
Yep.
Got
Yes.
it.
And when you do your designs, you see this clamping boss that's right here. If you make that boss wide enough, you'll be able to design it so that you can machine both sides without coming close to the vise.
Okay.
Okay, or you do
Cool.
do it the other way, and you do the top out of one piece and the bottom out of the other. You end up with more waste, but you know what? First time around, you don't want to be running into your vise. Maybe you sacrifice a little bit more material the first time.
Right.
Did you get it working?
Yeah, it was already working. We just had to prime it by shaking it. That's all we had to do.
All right. Well, thank you very much, guys.
Okay.
Okay.
And I might send you an email here
Sure.
with some of the things I said I was going to.
Yep.
But at least I got the one, while we were talking, I got the one thing, the HSM, the flange, I got that to mill out right now. So
Perfect.
that was the trick.
Good.
So at least that problem solved.
Very good. That's excellent.
All right. Well, have a good one.
Hey, you guys too. Have a great couple weeks. We'll be meeting again in 2 weeks. I'll post if you have anything any questions that you have between now and then, make sure you get them to us. Other than that, we'll put out an agenda for the next meeting, which will be in about 2 weeks, and we'll let you know.
Sounds good.
Okay.
Yeah.
Have a
This
great
is my first time teaching periodic lead-the-way curriculum, so we'll see how this goes.
Sure.
This, as far as SIM goes. Do either one of y'all teach DE?
I'm sorry, say that again?
Do you teach DE?
I do.
No.
I do.
You do.
I do.
What course did you take the new course?
No. I kind of learned all that stuff on my own.
Listen, I was in the first class that actually got the new curriculum.
Nice.
Oh, no, it wasn't.
Oh, no. Really?
No, there were 187 revisions during the class period, during those 2 weeks.
Well, thank
No
you.
joke.
I want to thank you in advance for ironing all that out. So when I teach it next year, it'll all be perfect.
I was ready to strangle people. It was 2 and 3 a.m. We finished Friday morning when everybody else was at graduation.